Today you are going to learn about linear modeling. You've probably learned a lot of this in earlier math classes, but now we're going to put it all together, now especially that you have a better idea of statistics, and then we're also going to have to use our graphing calculator. So make sure that you have your graphing calculator. So linear modeling, just a few things. So correlation is just the relationship between two variables. So if I have two variables, an x and a y, I'm looking at the relationship between them. So these are three kind of situations that we can have. So the first one, this has a positive relationship because they're going up and to the right, so think about the slope. This one has a negative relationship because it's going down and to the right, and this really has no relationship. It'd be hard to draw a line. Now maybe you could draw a horizontal line through there, but they're all super sporadic, so it doesn't really look like there's any kind of correlation between them. So those are just kind of the different pieces. Again, think of the slopes of the lines. We also can have outliers. The outliers don't follow the trend. So if we draw that line, this is an outlier because it's super far away from that trend line. However, down here, this isn't an outlier because it's still on there. So it still fits kind of that trend. Be really careful about causation. Just because two variables have some kind of correlation between them does not mean that one variable causes the other one to occur. So it is very possible that the length of your arms can correlate with your running speed. So maybe the longer your arms, the faster you run. But longer arms don't force you to run faster. So that's the causation piece. One thing does not affect the other. Or the number of dogs that run away and phone usage. So these might be related, however, one does not cause the other one to occur. So and we can come up with a whole bunch of different scenarios that, hey, look, this is what happens, but they really don't have any kind of causing. So like, for instance, when you look at students' GPA, so a bunch of people who are involved in sports. If you look at the GPA of the basketball team, let's say their GPA is really, really good. So maybe their GPA is like a 3.7. However, just because they play basketball doesn't mean that their GPA is going to be high. However, when you look at the majority of students, that might be the case, but that's not causing it. Basketball is not causing you to get good grades. There's some other things that are involved in it. Okay, so again, just be super careful about causation. That's a big statistical thing to look at, and people will use that as their excuse for different things to happen. So when we start going through and looking at this linear modeling, we're going to be able to find equations of lines and that sort of thing. And then there's also this Pearson's correlation coefficient. It's this R value. That R value tells you how close these dots form to that line. So how perfect is it? Here's how the correlation coefficient is found. We're going to use our calculator to do it. But that R value is represented in this graph, or in this table. So if R is 1, it is perfect. There's not a dot out of line. Every one of them fits a straight line. And if R is -1, it's the same thing. Because remember, a negative correlation just means it has a negative slope. So then it keeps going through. A very strong positive correlation would be between 0.95 and excluding 1. And then also vice versa. A strong positive correlation would be between 0.87 and 0.95. So if it goes from 0.87 up, you have a pretty good correlation amongst them. And then it goes all the way down to weak, moderate, weak, and then no correlation. So there's absolutely, I can draw a line through it, but nothing's going to fit. So what we're going to do is we are going to take some data, and we're going to find the R value of that data, and then we're going to look at the correlation. Like, what do I know specifically about this correlation? We are going to use this data set for 3 different examples. Okay, so we're going to go ahead and put this into our calculator. So grab those calculators out. So into the calculator, we are going to have to put in our statistics. So that's under Stat. And then we're going to have to edit it. We're going to have to edit what's in there. So hit Enter. I don't know if I have anything. Okay, I do. So if you have data up here, you arrow up, hit Clear, arrow down. That clears out all the data that was in there. And what you should have is list 1, list 2, list 3, etc. If you're missing any of these lists because you deleted one on accident, it's going to happen. You just go back to Stat and then set up editor number 5. We'll get you back into that. Okay, it'll bring them all back, and then you'll have to arrow up, hit Clear, arrow down. Okay, so what I'm going to do is I'm going to put all of the data from here, so I'm going to put all of those in for my x values. I'm going to put all of these in for my y's. I can just put them in the order that they're listed here. So I'm going to pause this. I'm going to ask you to pause it too and put this data into your table. And you definitely need to make sure that everything lines up in the end. So it looks like I had 12 items because that 13th one is blank, but making sure that you correspond that x term to the y term. So now that I have all of these in here, now it wants me to find the r value. And you're, again, going to do this with your calculator. So in order to find your r value, what you're going to have to do is you're going to go to Stat, Calculate, arrow over to Calculate. In order to find that r value, you're going to go down to this linear regression. And we'll come back to what linear regression is and all that kind of stuff. And so XList is your first, so that's your x value, so that's list 1. Your y is your list 2. I don't have any frequency. None of these happen more than once. So then I can just go down, enter, enter. If I wanted to store my equation, I can do that. I'll show you how to do that in a little bit. And it gives this to me. Now, for some of you, it is possible you don't have your r value. So what we're looking at is this answer right here. This is what I want. So my answer to it is 0.917. If you don't have that right now, don't fret. What we have to do is we have to turn your diagnostics on. So to do that, you're going to have to hit second and 0. That's your catalog. If your calculator ever gets reset, your diagnostics automatically go off. I don't know why or how that is, but it's just something that it does. So now I need to go down to D. So I clicked on my D because I need diagnostics on. And there it is. So I need it to be on. So then from there, I hit enter. And I turn my diagnostics on, hit enter again. And now for those of you who didn't see that before, now you can see that. So again, back to Stat, Calc, linear regression. And there is my r value. It's coming. Okay, so 0.917. So let's go back to our note sheet. So in here it said find the r value for the data. So that's 0.917. Describe the correlation between age and distance thrown. So when we go back to our table here, 0.917 lands in here. It's positive. And you're going to get negative. Negative would be in this list, so it would have a negative slope. So this, therefore, there is a strong positive correlation. So there is a strong positive correlation. AP and IB use different numbers for strong, very strong and moderate. So based on what course you're taking, they're all going to be super close to each other. Just be aware of that if you end up taking AP statistics. Okay, so that's the first one, is just finding that correlation coefficient and determining positive, negative, strong, etc. So now what you see here over here is a scatter plot of that data. So this is a scatter plot. So this is the age. This is the distance that you could throw. And they just put a random line on here. But does that kind of look like it's a trend? Like you can kind of see it's going up and to the right like that? And one of the things that you can look at, so there's 1, 2, 3, 4, 5, 6 points above. There's 1, 2, 3, 4, 5 points below. And then there's one that's right on the line. So, I mean, maybe we move this line down just a little bit because we've got a pretty substantial space between these, but there's not a lot of those. But then there's only 5 points down here. There's 6 points up here. So, again, totally random. So what we're going to look at is actually being able to find the line of best fit. And then we're going to be able to take that one step further and actually get the linear regression for it. So the line of best fit, we're going to have to be able to find the mean point. So the line of best fit will contain the mean point. And the mean point is just the average of the x's and the average of the y's. And it's one of the points that's on your graph. So you're going to have to calculate the mean of your x's and y's. Now the best part is we have this data in our calculator already, so it can find the mean of the data. Think back to when we were doing statistics. So going back here, just clear this here. If I want to find the mean of my data, I have to do both x and y separately. So calculate one variable statistics. So what I'm going to do is I'm going to find the mean of my x's first. So that's list 1. So I'm just going to go through and hit enter. And it gives me the mean, which is 15. So the x mean is 15. Now I have to find the y-mean. So back in here, so I'm going to do the same thing. Calculate one variable statistics, but now I want to do this with my y. So I need to change this from list 1 to list 2. To do that, here's list 2. Over here it's above the 2. So second 2, change it to list 2. Enter through it. There is my mean. So there is my mean now for my y's. So going back here. So the line of best fit has to contain the point 1529. So let's graph that on here. So 15 is halfway, 29 looks right about there. So that line's going to have to come down just a little bit. Now, whether it stays parallel or not, it doesn't really matter. But it has to contain that point. But that gives me a better idea of approximately how my line should be drawn. So now what I'm going to do, oops, I guess, oh no, I don't want to do that. There we go. So maybe we make it something like that. That looks like a much better line of best fit. Goes down a little bit more. There's a little less points here, a little more up there. Okay, so that's going to give you a better idea of that best fitting line based on knowing it has to go through this specific point. Lastly, what we've been using to find our R value is that least squares regression. So the least square regression line is really, it's going to go through that point, 1529, but it is the perfect equation that makes these distances. So if I draw my line from each of these in, that distance is the smallest possible error on both sides. So all of those on each side, zero it out. Some are negative, some are positive, so it goes through that way. So again, we completely use our calculator for this. So into my calculator, I can find this regression line. So back into your calculator, go back to stat, calculate. We're going to go back into linear regression. Now, one of the things that you're going to have to be careful of is see how in the X list it says list 2. We've got to change that back to list 1. So second 1, that's list 1. So now that's my X, that's my Y. And what I'm going to add this to is I'm going to store this regression equation so that I can graph it. So it's going to take this equation, it's going to put it in my y equals. That way I don't have any round off error because these are going to be ugly. So now what you're going to do is I need to tell this it needs to go under y1. So once I have this here, my cursor should be blinking here. I now go into vars, arrow over to y vars, function because we want to put this into y, and hit enter for y1. So now what it's going to do is it's going to store my regression equation into y1. So calculate. So my equation, A is the coefficient of x, B is my y-intercept. So therefore my equation for this is y equals 3.289x minus 20.34. So what I could do then is I can graph this, and I'm just letting my calculator do it. So I stored it in my y1, so there it is. Again, it goes all those decimal points out. So now I can graph it, and it will graph what it actually should be. So what I could do then is I could use this, and I can look at my table. If I wanted to graph it on my scatter plot, so I could put in this point, that's pretty far off, or I can pick any of these. This might not be such a bad one. This isn't too bad. But if I keep going, or if I do my table change, there we go. There's that point, 1529. There's that average. So that is one of the points that's directly on there. Okay, last thing to look at is when I have this data set, I can look at interpolating and extrapolating. This is on ACTs. Some of you probably saw it when you took your ACT. So we have these things that are called poles, and the poles are the lowest and the highest point, and then the data in between. The data in between the lowest and highest, again, going horizontally this way, that's called interpolation. So if I have this data here, I can get an idea of what happens in between here. However, if I look past my data, this is called extrapolation. So if I try to anticipate what would happen outside those marks, that's called extrapolation, and the data is very unreliable. So the data within here, this is reliable data. So if I look at any of these x values, I should get a good idea along this line of best fit. However, any data out here or out here that I'm trying to analyze, like what happened before I started recording my information, or what happens 10 years down the road, and trying to hypothesize what's going to happen or predict what's going to happen, the data can be very unreliable. This is the really reliable data. So again, just two vocabulary terms that deal with modeling. Okay, fantastic. You guys will have a worksheet on this then.